Okay, so you don't have a graphing calculator. How do you do this stuff in section 4 with the regression equations? Um, so there are applets you can buy. I mean, there's an app you can buy on your phone, something like called TI Calc or something like that. And that works well too. And it's cheap. It doesn't work as well. It doesn't work as well as the handheld one. So, but it does work. Here's another option, so you don't have to use TI technology or even an emulator. I do this with my statistics courses. If you click on this link here, that's going to take you out to, let's see, out of this Rossman Chance applet here. Let me refresh this page so it looks like what it's going to do when you open. Okay, see, it does a scatter plot. It's got a place for your data here. Let me get a pointer going. So it does the scatter plot for us. It gives us a place to paste in the data. You want to put your independent variable, your X variable on the left, your response variable, the dependent variable Y on the right, and that'll graph. And if you include text, it'll knows how to put labels the axis for us. Really nice. Got to make sure there's no spaces and only a space between those. Okay, but anyways, let's show you how to do this. So you certainly can type it all in. It doesn't matter, but here's from the textbook, and this will actually work for my open math too. Where's my textbook? Oh, come on. Oh, that's right. This computer is wonky about sharing screens. Here you go. So I've got the PDF version of the textbook open here, and this is the exercises, section 2.4. What page is it? 147. So what I did is this is just graphing. This is just graphing. I think what happens, I haven't done these. I think if these are linear functions. The points fall on a nice straight line. Maybe not. Maybe not. Maybe there's some scatter going on. Then these tell us we want to do the regression line and to get the correlation coefficient. And maybe those are foreign words to you, especially since this isn't a statistics course. So let me give a quick overview. So what I did here is I grabbed this data. Now you can copy it down from the top. Sometimes that works. If it doesn't work, copy it up from the bottom. And I'm copying it in my clipboard memory. And then I'm going to come back and try to find, here it is. Let's come back and try to find those Rossman chants. Here we go. So you have to clear out the data that's there. I'm going to paste it in. And it looks like, let's see if it likes it. It likes it. I see, so I'm going to put on my statistician's hat for a minute. I see a negative association, means as X goes up, Y goes down. It's a fairly strong linear relationship. So I talked about the direction, the shape, linear, the direction's negative, negative association. Notice I didn't say negative correlation. I just said it's an association. The correlation is going to be a number, and people misuse that all the time. So it's a negative association. It's a strong linear relationship. Now, how strong? Well, we can check this box. I'll show the regression line. That's the line at best fit. That's the best line at best fit. And if you want to learn why, take a stats course. Okay, I won't go into that. And here's the correlation coefficient. See, now correlation goes from -1 to +1, and if R is -1, it's a perfect. All the lines going in, all the points are nice line. They lined up, and it's a negative slope. If it's a +1, all the points are in a line with a positive slope, all in a line. Then there's some fluctuation in between, and that fluctuation goes from 0, where there's just a big cloud of points here that's not showing any kind of form. Versus like this one's pretty strong. You see how that's a correlation of -0.991? That's extremely strong. Doesn't usually occur in nature. Okay, so but that's the correlation coefficient. And if they want us to find R squared, there's R squared. And all they did is they took that, squared it. Now sometimes they'll want you to express it as a percentage. So you would just multiply the 98.983 times 100, make it 98.3%. And what you're seeing here with the graph, I mean, this is kind of going beyond what we need to do in this course, but what you're seeing is here, R squared tells me that 98.3% of the change in Y can be explained by a change in X. Okay, and then what is it, 1.7% is due to other factors that we don't know about. We aren't measuring. They're lurking variables, as we go to say. Okay. So that's the whole thing, the whole shtick between correlation, the correlation coefficient, R squared, shape of the line. Okay, so that's using that applet. It's a very cool applet. They do a lot. It does a lot for us. Yeah, I guess we don't need to do anymore. So hopefully this part helps. Let's see.